In this chapter, we will start interpreting our solution sets graphically. Okay, so we should start by talking about some geometry. Okay, so we'll start with a familiar looking equation of a line and come up with a maybe not so familiar equation that is equivalent. So here we have the parametric vector equation that is something of the form x vector is u vector plus t v. Anyways, we'll get to that. So what are we going to do? What do you want to do? What are we going to do? Well, we are going to, let's draw a picture first. So x plus 2y is equal to 4. When y is 0, you get x is 4. So we'll say that's here. So I go through that point. And then when x is 0, you get y is 2. So we'll say that point. So we get the line connecting those two dots. So something like that. Now, so I kind of missed my dot there, but you get the idea. What do I want to do? So I'm going to think about this line as consisting of vectors that start at the origin and end on the line. So we're going to think of it as consisting of all these vectors here. Now, if I have a vector, let's say I have a vector x, y that's on the line, what must be true? Well, I got the vector x, y. I can solve for x here. X is equal to 4 minus 2y, right? So x is 4 minus 2y. And y, we're just going to leave y as y. And if we pull this apart, we get 4, 0 minus y times negative 2, 1. Plus rather. Okay, and this is the equation I'm looking for. This is the x is equal to u plus tv up here. So here's my x. This is equal to u plus, well, here's v. And what we're going to do is we're going to say let y equal t. We call this a parameter. T is called a parameter. Okay, recap. What did we do? We said think of the line as consisting of vectors that start at the origin and on the line somewhere. And we looked at one of those vectors, called it xy, wrote it down here. We found that if you're on the line, x equals 4 minus 2y. So we made that replacement here. And we separated the right-hand side. And that gave us the equation we're looking for. xy is equal to 4, 0 plus t, our parameter, -2, 1. Now let's draw this picture again. Like this. Oh, that's not even close to straight. Too much coffee. Okay. There we go. And our 4 is say here. Our 2 is here. And our line in blue goes like. Oh, got a curve to it. Oh well, you get the idea. It's supposed to be a line. So where's the vector 4, 0? This is u. This is v. Where do those come into play here? Well, u is this vector that goes from the origin out to this point. And v is -2, 1. So what does that look like? Like that, and then something like this. So this says u there. That's v. -2. No, I screwed up v. Yeah, I screwed up v quite thoroughly. Can't you see? Let me try to do v again. V should be, here's -2. There's -1. Okay. V should actually go to this point here. Oh, it's hard to do straight lines on a tablet. There we go. That's v. So where was I? Okay, what I want to convince you of now is that if you take any vector x that is on the line, say x, okay, that is going to be u plus some multiple of v, right? So why don't you look at this diagram and say this x here, I can get to it by first doing u. First, okay, u is going to bring me here. Oh, that's not good. And then some multiple of v. You see how v here is parallel to the line. Some multiple of v is going to bring me to this point here, x. And that's true for any vector I want to draw anywhere on the line. If I drew a vector like here, or I drew a vector here, if I drew a vector here, okay, for some intelligent choice of t, that vector will be u plus tv.